Welcome to RCR Wireless News. I'm Martha DeGrasse, and I'm here with Marquis Dorais. He is Fronthaul Product Line Manager at EXFO. Marquis, thank you very much for being here today.
Thank you, Martha. Thank you for having me today.
Our topic today, obviously, is fiber and fronthaul. So I'd like to start off by hearing about the biggest challenges that you think MNOs face when deploying fiber in mobile networks.
Yeah, it's a great question. Maybe I would start off by saying that the traditional mobile installations use copper to interconnect the base station equipment to the antenna sites. It could be at the top of a tower or maybe at a rooftop. But I would say this type of architecture, because of the high power loss in the copper cables, it does not scale well for future 5G type of networks where centralization of the BBUs, the baseband units, the equipment that's typically at the bottom of the tower, centralization is absolutely needed for 5G. And when we talk about centralization, the BBUs could be placed miles or kilometers away from the actual antenna site. So for this reason, there's a move towards what we call FTTA, fiber to the antenna, or even CRAN, centralized radio access networks that are becoming common today. And the move towards FTTA and CRAN really does add a lot of benefits or advantages to mobile network operators all around the world, so MNOs. But it also includes, I would say, a fair share of challenges and issues. And the fact that one biggest point in there is the fact that optical fibers is often new to the mobile industry for the guys that are working in this, does add a lot of complexity during the installation and during the construction of the mobile cell sites. Just for example, in a CRAN network, how do you actually ensure that you don't have maybe dirty connectors that could potentially degrade your optical signal between the BBU and the RH? How do you find let's say a macro band, a bent fiber in a fiber span that could span up to 10 kilometers for the fronthaul? How do you pinpoint and find, let's say, for example, a missing fiber interconnection? How do you ensure that, for example, that you've connected to the correct port, let's say at the RH, or that you have not reversed your fibers at the RH itself? So how do you confirm all that? Well, this is where you actually need a fronthaul test solution to help you out with all these potential issues. And without the right testing solution, without something that's really essential, the right testing procedure, field technicians could actually spend hours and in some cases even days troubleshooting some very common issues that we run into every day when helping out during these network installations. And in the end, I would say this translates into huge costs for mobile network operators all across the world.
Okay, great. Are there any other specific challenges related to the presence of those active optical components in that link between the BBU and the RH?
That's another good question, and I would say that with what we call the RAN evolution from the traditional copper-based mobile installations that have now been replaced with fiber-based mobile installations, as I mentioned earlier. For example, with DRAN, something that we call distributed radio access networks, where the actual BBU, the baseband unit, is installed at the antenna site, and your interconnection is between the BBU and the RH are done with fiber optics in that case. With CRAN, with the move towards centralized radio access networks, in order to reduce what I call the fiber count, the amount of fibers between the centralized BBUs, those BBUs that could be located in a data center, for example, just to reduce the amount of fibers, you need active transport equipment between the BBU, let's say the BBU hotel, and the actual RH site. And these active transport equipment will use technologies such as CWDM or even DWDM. These are transport technologies that will be used to actually take in all those CIFRI links and merge them all onto a single fiber to and from the BBU hotel and the actual antenna sites. And in active CRAN networks, since there's active equipment between the BBU and the antenna sites, the complexity of the mobile installation itself increases. even there's added complexity just in terms of the actual network architecture that's being implemented. And something I discussed recently with a tier 1 MNO in the US is that they mentioned that 60 to 70% of their active CRAN deployments today have installation issues from the get-go. So issues could be such as improper configuration of the active transport equipment. It could be improper colored optics that are being used. When I'm talking about colored optics, I'm talking about, let's say, CWDM or DWDM actual SFP modules. In some cases, it's the wrong modules that are being used. And in other cases, it's just simple fiber interconnection issues, just by the sheer fact that there's a lot more equipment that is involved in the whole fronthaul testing solution. So really to overcome all these issues and these challenges, I would say that there's a need for a proper testing solution and really to help the installation and verification teams. And at EXFO, this is one thing I think we do very well, is that we work closely with MNOs and their teams to actually develop something that we call a MOP. It's a method of procedure to really minimize and even in certain cases even eliminate all these installation challenges and issues that we're talking about today.
Okay, great. Now you mentioned CPRI links, Common Public Radio Interface, and another protocol that we hear a lot about in this context is OBSI. Can you explain the difference between those two?
Yep. So as I mentioned before, with the move towards fiber-based mobile installation, the base station equipment has been actually separated into two pieces of equipment today. So there's the BBU, which I mentioned before, the baseband unit, and there's the RH, the remote ready head piece of equipment. The BBU is typically at the bottom of a tower or maybe centralized in a data center. The RH itself is, which is actually composed of two components, is the radio and the RF amplifier, is actually mounted at the antenna site, very close to the antennas themselves. And the interconnection between the BBU and the RH is done over fiber optic cable, and the actual digital RF information that is transported between these two equipments is using one of two protocols. So it could be either CPRI, which is Common Public Radio Interface, or it could be OBSI, which is the Open Base Station Architecture Initiative. And with CPRI, it's a specification that was actually initially released way back in 2003, which actually defines I would say, the internal interfaces between the BBU and the RH itself. And the vendors that were working on the CPRI specification cooperated together. Vendors such as Ericsson, Huawei, NEC, and Nokia. On the OBSI side, again, it's similar in terms of its interface specification. Was initially developed in 2002, so it's a bit older in terms of specification, and it was created by companies as ZTE, Nokia, Samsung, and LG. I would say that both protocols have something that's called a CNM portion, which is the control and management, and they also have a data transport portion. The CNM, again, control management, is really used for internal communications between the BBU and the RH itself. For the data transport portion, it's used for transporting the RF signal, the analog RF signal in a digital format. And this format is actually called IQ data, something that people in the communication industry are very familiar with.
IQ data, is that what you said? IQ data?
IQ data, correct. Yep, IQ data. On the OBSI protocol side, the control and management portion has a very clear definition, and it really allows for equipment vendor interoperability. In contrast to that, on the CPRI CNM portion, if you want, it's vendor specific. So there's no possibility for equipment vendor interoperability, meaning let's say if you have a BBU from Ericsson, it will not interoperate with, let's say, Huawei or Alcatel-Lucent or Nokia, and vice versa. And maybe a small point to make here is some people in the industry call CPRI, instead of calling it Common Public Radio Interface, they actually call it Custom Proprietary Radio Interface, just by the nature of it being vendor specific. And maybe I would say the last point I would like to make on CIPRI and OPSI is the fact that on a worldwide basis, CIPRI has roughly 95% of the worldwide market today. And one key point there is that there's an evolution of the actual specification. There was an actual specification that was released fairly recently, October 2015, and it specifies data rates of up to 24.3 gig. On the opposite side of that, OPSI specification defines a maximum data rate of 6.1 gig, and that was actually back in 2010. So there was no evolution of the actual specification for OPSI. So I would say those are the main points between the two protocols on that side.
Okay, terrific. Well, we have talked quite a lot about some of the challenges inherent in testing fiber-based networks, CIPRI, OPSI as well. All that said, where does RF fit into this picture?
It's a great question, and this is something that brings a lot of new interrogations for mobile field techs in the industry. And I would say today, I mean, with the increased competition, it's really forcing the mobile network operators, the MNOs, to focus on OpEx savings and how they can quickly and efficiently deploy more mobile cell sites. And really from this comes the fact that mobile field technicians are now being asked to do more than ever before. And on that front, if you look in the past, the major focus for a mobile field technician, for example, was really on RF testing and validation. And today, with the move towards FTTA, fiber to the antenna, or even CRAN, mobile techs need to be, I would say, a lot more versatile and really expand their optical expertise and even their protocol expertise, something that they didn't really have to do in the past. A new term that is often used when we talk to our customers is hybrid techs. And this really means that mobile technicians today are now responsible for example, for fiber testing. So that means that they have to have, in some ways, in some capacity, optical expertise. They also have to do protocol testing, either over CIPRI or OPSI. So on that sense, it means that they have to have some level of protocol level expertise. They also have to do something that's fairly new in this industry, is RF spectrum analysis over CIPRI or over OPSI. And again, that brings its share of new expertise. And all this along with the traditional expertise that they had, which is analog RF testing expertise. And from this, based on all these new skill sets, there's test and measurement equipment today also needs to, I would say, to really adapt to these changing realities. And the test and measurement industry has to provide test solutions that provide mobile field technicians and contractors with all these testing requirements for their, I would say, for their day-to-day working activities. One thing that is, I would say, is crucial is to have a fronthaul test solution that combines all these testing functions that I mentioned previously, so optical protocol with CIPRI, with OPSI, even RF spectrum analysis over CIPRI or even OPSI, and even having the capabilities to do what we call over-the-air testing capabilities with RF. And having a test solution that combines all this, in the end, really helps MNOs to reduce, I would say, truck rolls, and also reduce the number of tower climbs, which is, as we know, is extremely expensive in the industry. So all this really comes down to saving costs for the MNOs and also for the contractors. And the last, probably I would say, last key point I would mention on this is the fact that at EXFO we've been working really closely with all the top tier 1 MNOs operators around the world. And with the collaboration that we share, the partnership that we share, we design I would say, a truly unique fronthaul test solution that combines all these testing functionalities into one all-in-one test solution for the fronthaul industry and mobile industry as a whole.
All right, Marquis Dorais, Fronthaul Product Line Manager at EXFO. Thank you very much.
Thank you, Martha. Thank you for having me today.